because what you, the unsung heroes in the wastewater industry, do matters. Every Wednesday, join me, Suzanne Chin Taylor, the DooDoo Diva, a longtime veteran of the wastewater, trenchless, and civil infrastructure industry, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. I'll also be speaking with representatives of organizations that are utilizing disruptive or new technologies, and executives who are going to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Hello, I'm Suzanne Chin Taylor. Today, we're visiting with Michael Pringle, Director of Operations for FLOVAC Americas. Welcome to the show, Michael.
Thank you, Suzanne. I appreciate the time.
Michael's firm, FLOVAC, is the world's largest operator, supplier, designer, and manufacturer of municipal vacuum sewer systems. Vacuum sewer systems have been utilized in over 50 countries since the 1960s. And Michael is going to share with us today how exactly this technology works, its applications, and the unique properties and advantages of this type of sanitary collection system. Michael, I've learned a little bit about vacuum sewer systems since we first talked about you being a guest on the show, but there's probably a lot of people just like me who we've heard of it, but we don't really understand it or know too much about it. So what I'd like you to share with us today is maybe what we could term Vacuum Sewer Systems 101, so we could understand the basic principles behind it and how it differs from those traditional systems, gravity-fed and septic systems that we've all become very, very familiar with because it's been utilized so much in the world.
Sure. Thanks, Suzanne. I appreciate the introduction and looking forward to chatting today. So a vacuum sewer collection system, it comprises mainly of three parts. There's the heart of the vacuum sewer system, which is the vacuum station. There's the collection pipework that extends from the vacuum station throughout a neighborhood or development. And then there's what we call a valve pit, which is typically served by 1 to 4 houses, and that sits in the right-of-way. What happens is at the vacuum station, a negative pressure is created within a holding tank. That negative pressure is then transmitted through the collection network to the valve pits, where it's sealed off by an interface valve. Once 10 gallons enters the sump of a valve pit, the interface valve opens. Pneumatically, there's no power needed, and the pressure differential between the negative pressure in the line and atmospheric pressure is enough to propel the sewage down towards the collection tank at the station throughout the pipe network. Once the sewage is collected at the vacuum tank at the station, it is then pumped from that tank via sewage pumps. It can either be pumped next door to a treatment plant, or it can be pumped miles away to a treatment plant or into an interceptor gravity system, whatever is needed for the area that the system is applied in.
So you brought up a good point. You said an interceptor gravity system. So these systems can work in conjunction. They play nice with the traditional municipal gravity systems that may already be in place, if I'm understanding you correctly.
That's exactly right. There are a number of systems I can think of that will have a vacuum sewer collection system, and then they might pump across a bridge to a larger municipality with a gravity system that can handle the flows. They can also just pump directly to the treatment plant.
Okay, great. Thank you for that explanation. Now I'm getting a better picture of how this works. So you had mentioned there's no power needed. So there's no electrical power that has to be run to these systems.
Yeah, that's correct. The only power that's required for a vacuum sewer system is at the heart, at the vacuum station. At the vacuum station, we have vacuum pumps that create the negative pressure in the tank. We have the sewage pumps that we just referenced that pump the sewage from the tank to the end treatment plant or gravity system. At the vacuum pit itself, which collects the laterals from the individual households, that valve, that interface valve, is opened entirely by pneumatic pressure. So no power is needed from the individual household to maintain the system. This is great for systems that are prone to extended power outages, either by hurricane or other natural disaster. The system will keep running. All you need is a generator at the heart of the system at the vacuum station.
That also makes it a little bit greener of a technology as well, because it's not needing power to run it. Wow, what an
Exactly right. Yeah, and there's some installations we actually are now using solar panels to assist powering the vacuum station itself.
Yes, I can think of a number of places around the world where power and power stability can become an issue. And so you're saying the solar power backs up the backup generators to keep everything humming along.
That's exactly right.
Great, great. All technologies have pros and cons. So in looking at your traditional systems of gravity and septic versus vacuum, where would this come into play as being a better alternative, or at least something that should be given serious consideration?
Sure. So typically you're going to see a vacuum sewer system installed in an area that's extremely flat, has a high water table. It might be environmentally sensitive, or say, think a development where excessive amount of lift stations are needed. Resorts, again, environmentally sensitive, areas over water, cabins, marinas, or wetlands.
This sounds like it's a viable alternative for new development, and also for the use of replacing areas where people are on septic and they want to convert them to municipal wastewater lines. I'm curious, could this be utilized as a means to rehabilitate sections of an aging infrastructure system, similar to just considered being used almost like a trenchless technology?
Sure, it can definitely be used for abandoning old, say, gravity system, for example, and it has been done so. And the project I'm thinking of off the top of my head, the municipality was actually able to sell the old gravity system to a telecommunications company, and repurpose that accordingly. Because of the minimization of the disruption to the neighborhood, again, think shallow trench depth working down the side of the road versus a gravity system that would be down the center of a road and can disrupt the neighborhood largely. It is, in some instances, a great solution for replacing aging or older infrastructure.
I've been interviewing a lot of cities lately, and the common pain point that seems to keep coming up is I&I, and sealing off the system. And many times they're coming through and they're doing CIPP lining on the main, and then they're finding, oh, we're still getting leakage coming from the laterals. And then, oh yeah, well, we're still getting stuff from the lift stations and the manholes. And it becomes very costly to seal off that whole system. And as long as there's I&I, they're thinking, oh, our answer is, well, we're getting more flow come in, so we'll just increase the capacity of our plant. But that's kind of like putting a Band-Aid on something that really needs stitches. So I'd like your opinion on, as we were talking earlier, looking at replacing those traditional sections where there is a lot of influent infiltration with a vacuum sewer system or components. That could this be an effective solution for those areas that have a tremendous amount of I&I? And what would that be looking at in cost comparison to traditional lining or using these other methods to seal off the system versus replacing those areas completely with a vacuum system?
Sure. So I think the first part of the question is, if you are looking to take an area of a municipality off a gravity sewer system, you'd need to look at the project holistically. Typically, a break-even point for a vacuum sewer system is 100 plus houses, anywhere up to 3,000 on one system. Obviously, you can have multiple systems. So that you need to take that into account, whether you're just repairing a section of a gravity line or whether you want to replace a larger network or neighborhood development, if you will, with a vacuum sewer system. As far as the I&I goes, it's really interesting for me. I find that you're exactly right. A lot of the conversation is around the larger scale collection pipes in a gravity system. For us, because the vacuum pipework is under a negative pressure, we don't have any problems with I&I. If you did, it would have to be repaired, and it's easily identified. So we are now focusing more on I&I from homeowners' laterals or from commercial users, etc. And we're able to do that by using our monitoring system that tells you exactly how many times a valve fires, in turn, how many gallons are coming out from that user.
Another issue, of course, that cities talk about is, I'm putting this in quote, flushable wipes, which we all know are really not flushable and can be a real problem.
Sure.
How does a vacuum system deal with that in comparison to maybe other systems? Is it okay with it, or are there going to be issues?
Sure. So let's take a ride. If we were the flushable wipe, the first place we're going to end up is the vacuum collection pit. It's a 3-inch full port interface valve. And there is a number of videos online that we've done testing to see what this thing can handle. And flushable wipes are not a problem. Secondly, that wipe's going to make its way through the collection network piping. Because of the pressure differential between atmospheric and the negative pressure in the pipe, the sewage is actually moving about 15 feet per second. So it has a huge amount of scouring velocity, which keeps those pipes spotless. No manholes are needed for cleaning, etc. So there's not a problem there either. The wipe will then end up at the vacuum station in the collection tank. From there, it's passed through the full port sewage pumps and it'll end up at the screen at the treatment plant. We don't have problems with them.
Okay, great. But again, we still have to discourage, because as you were saying, it ends up at the screen at the treatment plant, and even there, it's still a problem. So
Sure.
I understand that the installation process for a vacuum system is very, very different than a traditional septic or gravity feed. Can you kind of go through some basics of the installation process, what's involved, the timeline, common things? I know every case and every situation will be different, but what are the most typical things that you will see in an installation so that our viewers can understand what happens?
Installation of a vacuum sewer system kind of gets broken into two parts, and you can install these parts simultaneously. So you're going to have the collection network and the vacuum valve pits being installed. And secondly, the vacuum station is going to be being built. So you can run the two simultaneously. We talked earlier about timeline. Medium-sized vacuum collection network might be from 9 to 12 months. We talked about the shallow trench step, so you're not disrupting neighborhoods. You can work quietly down the side of the road, allowing driveways to be opened again at the end of each day. There's a lot less disruption to neighborhoods.
How do vacuum systems compare to traditional gravity systems, cost-wise, for a municipality?
Sure. So for the municipality, for install costs, you're looking at, as we spoke earlier, about 30 to 40% less than a traditional gravity system for install. Operationally as well, depends on the municipality, but your cost per connection is going to be a lot lower as well.
And it sounds to me like it's going to lower overall maintenance costs of the collection system as well for your municipalities.
You're exactly right. Yeah, the main return on investment obviously is keeping the ground and the stormwater out. Our valves and controllers are warranted for 10 years, and even then they weigh 15 pounds and require about an hour's worth of service. So the maintenance on these things, once you know what you're doing, is not all that.
Michael, who would you identify as the ideal candidates, customers, or applications for a vacuum sewer system?
Ideal candidate for a vacuum sewer system is going to be a municipality looking to get residential houses off septic systems, new developments that require excessive lift stations, irregular shaped developments, again, that require excessive lift stations, environmentally sensitive areas, resorts, and the like. And that can include commercial properties as well. So again, flat, high water table, or difficult terrain is key. Marinas would be another one I'd touch on as well there. You can actually incorporate the marina and the adjacent land in one system.
Okay. How about any industrial or process water applications?
Sure, you can definitely do that, and you need to size the system accordingly for that. The system doesn't know where the water's come from. It'll handle it appropriately.
What type of routine maintenance is required on a vacuum system? What should an owner considering this be prepared for?
I think there's been a lot of development in the last 10 to 15 years around the maintenance and the cost of maintenance required on these systems. Now with monitoring, you can see exactly what the valves are doing out in the field. That's minimized a lot of what used to be going to walk and check the valves. But there are still some routine maintenance things that need to take place, whether it be oil change on the vacuum pumps, cleaning the collection tank every so often. That sort of basic thing.
Basic things, nothing too complex.
Nothing too
Or
complex.
costly. Are there many moving parts? Do they have to consider that there's going to be a lot of consumable parts replacement, spare parts that they need to have on hand for the system?
There are, consumable or spare parts that are specific to a vacuum system. The valves and controllers and their associated parts will be one of those items. But the neat thing about a vacuum sewer system is that the vacuum station is enclosed. It can be conditioned airspace, and so they're really nice to work on.
Okay. And so it's not a messy job like your traditional gravity-fed sewer.
Not so much, no. Even the collection pits themselves, they have a floor in them, so you're not actually subject to the sewage that's being collected below. Again, the valve is easy to take out, and easy to replace if there ever was a problem.
Well, that leads me to the question for operations. Is confined space entry required to maintain these systems?
If you were cleaning the collection tank, yes, most definitely. That's definitely a confined space. That doesn't happen but once a year. Otherwise, the vacuum valve pits out in the field, no confined space permits needed.
Wonderful. Wonderful. Do you anticipate that this technology is going to gain more widespread acceptance as more people know about it or the advantages of it?
I would like to hope so. That's my goal. Definitely. So, yeah, I think we're seeing the effects of what septic tanks are doing to our waterways. It's becoming more obvious. The data's been out there for a long time. Septic to sewer conversions are gaining momentum. The fact that it's a low disruption to a neighborhood and environmentally friendly system as well, which is the whole reason we're converting these septic tanks. I think is a huge plus. And so, yeah, we're definitely expecting to see some growth. There's also advantages. There's been some negotiation or some talks around whether a vacuum sewer system should be applied more points when applying for funding because of its environmentally friendly nature.
How can we make the market more aware of this alternative and open that thought process for maybe we should look at this a different way? Who can help with that discussion?
Sure, and that's a great question. And we spoke earlier about training an operator of a system. The other part is we need to train our engineers, our developers. Look, there is an alternative out there. It's not taught in engineering school. And so I think that's half the battle is the training. New development could definitely be, it is definitely a viable option for these systems. Obviously, you want to make sure that your municipality is willing to accept an alternative sewer system before they pushed ahead with that. But we know there's cost savings there. It's just a matter of getting the information out there and making people aware of this product.
Okay. What future advancements should be expected for vacuum sewer systems? As you know, technology is always improving.
Sure, I think there's been a huge changes in the last few decades already, and we still haven't realized all of those changes on existing systems in the Americas yet. But you're going to see things along the line of self-diagnosing, self-healing systems. The cost reduction for connection is going to keep coming down, either for capital outlay or ongoing costs as the monitoring system progresses and just gets better and better with the more information we collect.
That self-healing, explain that to me. What do you mean by a self-healing system?
Yeah, so that's sort of under wraps a little bit still from our end, but it's essentially if there was a problem, it would help the operator by maintaining the system integrity until the problem was fixed.
Ah, okay. Michael, how many of these systems have been installed worldwide, and what major countries are you currently operating in?
FLOVAC Americas has 300 plus projects worldwide. We're in Spain. There's a system there that actually, you talked about it earlier, a conversion of a gravity system that was inundated with seawater that was replaced with a vacuum system. New Zealand, earthquake prone areas, we use PE pipe, it'll adjust with the ground. We're obviously in the Caribbean, the Americas, Greece, France. A new system went in recently in Botswana. They chose it for the ease of operation and the monitoring system. Hilton Resorts recently put a new system in, a large resort there, marina. That was extremely high flows. Super yacht marinas, we're doing a number of marinas that have been coming out lately with a vacuum sewer system as well.
Very interesting. Well, if you would like to know more about vacuum sewer systems, you can contact FLOVAC.com in the Americas. If you are a viewer that is watching from a place outside of the Americas, they have offices all over the world. And on their website, you can see their global directory to find an office that's near you. Michael, I want to thank you so much for spending time and helping us learn more about this alternative sewer system. It's fascinating. I see it as the wave of the future and something that can really help world environment as our aging sewer systems. We're off any municipality that says, oh, we don't have aging sewer system problems. They're fooling themselves and lying to themselves, as you know. So yeah, this is a great alternative that they should be definitely considering. And thank you again for your time.
No problem. I appreciate you making time for me. Thanks.
Thank you again for joining us. Hope to see you again soon. Thanks for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. Be sure to subscribe to the show so you'll never miss an episode. And while you're at it, if you found value in this show, we'd appreciate a rating on iTunes, or simply tell a friend about the show, because that would help us out a lot too. If you're an industry expert and would like to be considered as a guest for the show, email guest@smellslikemoneymedia.com. Tell us a little bit about yourself and the topics you'd like to talk about, and we'll be in touch. For more information about our family of marketing, international business development, and workforce training companies dedicated to the empowerment and education of our industry, call us at 760-217-8010 or email me at raven@creativeraven.com. Until next week, a big shout out to all my industry friends and those who will be. You're my superheroes.